Okay, so this is day one here of our online math learning. Hopefully your Monday and Tuesday went pretty good. And we're going to kind of start light. We're going to do a little bit of chapter 3 review stuff. I'm going to try to get you guys going on Khan Academy. And then tomorrow I'll try a little something through Flipgrid that you guys can do like a video response to. And then obviously, feel free to pop into the Google Meets today and tomorrow. But I hope you guys are doing well. I'm just going to jump right into it so you don't have to listen to me for any longer than you need to. Okay, so this should match up with the Khan Academy sections. If it's not in the same order, I apologize. But if you give me that feedback, I might be able to fix it for the next time. So first, we're just being asked here to plot the numbers on the complex plane. So remember that when we're talking about the complex plane, we are talking about the horizontal axis as our real axis, and the vertical axis is our imaginary axis. So 3 real units will be right there. -7 imaginary units would be right there. So to plot that complex number, 3 minus 7i, you're looking at right there. And then we had actually taken this a little bit further before we left. And the Khan Academy is not asking you to do that, so not a big deal. But we can just real quickly do this. We know that's 3 units. We know that's -7 units. And you can real quickly do your Pythagorean theorem. And you can find that distance, okay? So we'd be looking at 9 plus 49 here equals d squared. That's going to be 58. Square root both sides, and there you have it, okay? So just, again, not being asked to do that on this assignment, but we had done that in the past, so just wanted to point out how that relates back for you. Okay, so that's one type of problem you're going to do, and it should be about 4 problems on each. Then multiplying complex numbers, and this again is something that we had worked through before we left. But same idea as whatever you did, whether it was rainbow method, whether it was FOIL, I just call it all distributive property, but same method. So a -2 times a +1 is a -2. -2 times a -i would be a +2i. -4i times 1 is a -4i. -4i times a -i is a +4i squared. Okay, so pretty much as always, or oftentimes I should say, you're able to combine your 2 middle terms there. So we're going to combine that to a -2i. And then the thing you have to remember here is that anytime you see an I squared, you want to substitute a -1. Okay, that's going to get you to this. Combine now your -2, your -4, and there you go. Okay, you can also write that out in component form, which is just going to look like that. So either one there, this one's called rectangular form. And this one would be component form. Okay, and that's really all you have to do. So really nothing new. Same math as you have always done, with the exception that when you see that I squared, you're going to want to substitute a -1. Okay. So, solving quadratic equations. And this is probably the hardest math you have to do. First, we're going to look to complete the square. This is the method we probably worked on the most. So remember, to complete the square, your a value has to be 1. So we're going to first have to divide out that 2. Okay, so that's going to give you x squared plus 3x minus 1 equals 0. Then you're going to vacate that c spot. So add 1 to both sides. And then you're doing your little magic trick, b/2 squared. b in this case is 3, so 3 over 2 squared would give you 9/4. You're going to add that here, and you're going to add that here. Okay, so that number right there you have to add in here, which is going to make that trinomial a perfect square trinomial. And then to keep the equation balanced, you also have to add it to the other side. Okay, so we already know the factor. It's going to come from right here, so it's going to be plus 3/2. And that's always going to be a squared binomial, because like I said, we made that a perfect square trinomial. Okay, and then on the other side, well, we know 1 as a fraction is going to be 4 over 4. Okay, so we can just go ahead and change that 1 to a 4 over 4. That's going to give us 13 over 4. Square root both sides. You're talking about now x plus 3/2 equals plus or minus the square root of 13 over the square root of 4, which is 2. Go ahead and subtract that 3/2 over. And you're pretty good right there. Okay, you can, if you want, since we already have a common denominator, and you're gonna most of the time see that when you're completing the square, you can pull those together and make it one fraction. -3 plus or minus the square root of 13 over 2. So that's a pretty good one there for completing the square. You do get into a little bit of fractions, but nothing that's too limiting, so pretty doable. Now, the Khan Academy especially had a couple ones that would be kind of gnarly to do with completing the square. So how to know that is you look right here, you have a -5 as your a. Well, if I go through and divide everything by a -5, I'm going to end up with fractions all over the place, right? So we're going to try to avoid that. So let's take that out. Okay. And you can do other methods, but I think quadratic formula is probably going to be the easiest to get you there. So remember, that's -b plus or minus the square root, b squared minus 4ac all over 2a. Make your substitutions. Okay, b is a positive 1, so -b plus or minus the square root of b squared minus 4 times a is a -5, c is a 2. All over 2 times a, which is -5. Okay, and then really you're just simplifying. So that's -1 plus or minus the square root of 1. -4 times -5 is a positive 20, times 2 is a positive 40, over a -10. And that's -1 plus or minus square root of 41 over -10. And that does it for quadratic formula. Okay, so if you're looking for solutions and completing the square looks like it's going to kind of give you some tough fractions to work with, you can always go back to quadratic formula to get those solutions. And if you do end up with a negative number under here, which is called your discriminant, then you're going to end up with an imaginary root, and that's fine. Just pull out your I. Okay, and I think this is the last thing for today, is working with quadratic systems. So we are solving systems of equations, which means we are looking for the point where these intersect. So if we take y equals 4x times x minus 2 and x plus y equals 2. Well, we're probably going to be best off getting these both equal to y, and then from there you can go ahead and set them equal to each other. So that's what I'm going to look to do with that equation there on the right, and it might jump out to you that that is a linear equation. Okay. So before I do anything, I'm going to subtract the x right there. Now I have them both equal to y, so you can set them equal to each other. Okay, and now since we're going to be combining, you're going to want to multiply out. So that's a 4x squared minus 8x equals 2 minus x. Okay, that's, once you see that squared, probably pull everything onto the same side. So 4x squared, add the x, subtract the 2, and now you are ready to solve. You could complete the square. It looks like it could be pretty tough here because you'd end up with a b that's kind of hard to work with. Quadratic formula is obviously not a bad option if you wanted to do that. You could also just look to factor it, see if you can get it to work using diamond problem generic rectangle. A couple of different options here. So I'll go ahead and just review quadratic formula again. I think people probably prefer that when it comes to solving. So I'm going to scroll this up here a bit. Okay, so x equals negative b plus or minus the square root of b squared minus 4 times a times c all over 2 times a, which is, should have made that substitution, sorry, which is 4. That's a positive 7 plus or minus the square root, 49. That's a minus 16 and then a plus 32 over 8. 7 plus or minus the square root of 81 over 8. Okay. Continue on here. Actually, I'll go a little further than that even. So that's going to get us now x equals, well, square root of 81 is 9. 7 plus or minus 9 over 8. 7 plus 9 is going to be 16, divided by 8 is 2. 7 minus 9 is a negative 2, divided by 8 would be a negative 2 over 8, or a negative 1/4. Okay, and you can do that part on your calculator, 7 plus 9 divided by 8, and then 7 minus 9 divided by 8, and that'll work for you. But then you have to keep in mind here that when we are trying to solve a system of equations, okay, we are looking for points. So right now, all that we have is x values. So you're going to take the simpler of your two equations, which is obviously the 2 minus x, and substitute. So when we put in a 2, well, that's pretty simple. You get a y is 0. So there's one solution. When x is 2, y is 0. When I put in a negative 1/4, well, first of all, 2 is going to become 8 over 4 minus a 1/4. That's going to give you 9/4. And there is your second solution. When x is negative 1/4, y is 9/4. So that's quite a bit of algebra involved there, obviously. Okay, but I think also pretty doable. Okay, now I'm going to go ahead and just put these on a graph. So I don't know if you saw, but the other day I had posted a possibility for an app for a calculator. And if you go to graph n calc 83, so GRAPHN CALC 83, if you go to that in your app store, you'll get an app for a free graphing calculator, and then you can do some of this stuff if you want to. Okay, now for these we did have to solve them both for the y, so we do have to use the y equals 2 minus x after you've done that. But then, let me try to get this on the screen for you guys. I'm going to scroll up here. Okay, all right, that'll do. Get that in there for you. Okay, and just to kind of show you, so the 2 points that we found would be, you're gonna have at 2, 0, and you can see that pretty clearly, right? 2, 0 is gonna be right there. My pen is not working on the graph. There it is. 2, 0 right there. Okay, and then our other point, which would be negative 1/4, 9/4. Well, negative 1/4, 9/4. 9/4 is obviously just a little bit more than 2. And there you go, right there would be the second point of intersection. So again, I know not everybody has the access to a graphing calculator, but if you're willing to put that app on your phone, it worked pretty good. I tried it out. You'd be able to do some graphing. One of our Google Meets that can help you out because it's a little bit different than the Inspires we've been using. But yeah, see what you can come up with there. We'll have our office hours here coming up a little bit later if you guys have any questions on these Khan Academy problems.